Okay, we're back. We're going to continue to take a look at the remaining 14 questions that are on the practice test, beginning with question 37. And this is going to be 3x to the third plus 6x squared y minus 45. And it says to factor the trinomial completely. So 3x to the third plus 6x squared y minus 45xy squared. So, among the last videos that you should see at the end of chapter 4 is what we call factor completely. And as I mentioned in those videos, the first type of factoring you always need to look for is what the greatest common factor is going to be. So that's what's going to be applied in question 37 here. So I'm going to put that here. For 3, 6, and 45, 3 is the greatest common numerical factor. For x to the third, x to the second, and x, all three terms have an x. We go by what the lowest one is. So this is x to the 1, so we're going to factor an x out. So 3 times 1 is 3. X times x squared will give me x to the third. So I have that. 3 times 2 will give me 6. X times x will give me x squared. Then we have y. 3 times negative 15 will give me 45. And then this is going to be 15y squared because x times 1 will be just x. Now from this point forward, if you have like this game where you have like an x to the second here and y to the second here, just know that the first term is going to be an x. The second term is going to end in a y. Now, it won't be just y. We're not sure what that's going to be yet, but we're going to try to figure that out. Just make sure that you bring the 3x down for that. And we're going to bring our x box to the side for this and try to figure this out. So, a is 1. B is negative 15, so that's going to multiply to negative, or C is negative 15. That's going to multiply to negative 15, and then this is going to be 2. So we want two numbers that multiply to 15, but because they multiply to a negative, that means they're going to have a difference of 2. So hopefully people will realize that that's going to be plus 5, that's going to be minus 3. Positive 5 times negative 3 multiplies to negative 15, but 5 minus 3 will equal 2. So when I write this in now, this would be like plus 5. This is going to be minus 3, and now we have this factored completely. And if I'm looking at the choices correctly here, I have them written the other way compared to the choice, but that doesn't matter. That's going to be choice C on the practice test that you have. Next, 38. Another one we got to factor completely. And in this case, this is, we end up not being able to factor that 15 out, so we're kind of stuck with the 15. So let's go ahead and write that down for 38. 15y squared minus 16y squared plus 4. So in this case, when we do a times c, it's going to be 15 times 4. And that's going to give me a product of 60. So I'm looking for two numbers that multiply to 60, but that somehow add to negative 16. Now, if they have a negative sum, but a positive product, that means the two numbers we're looking for both have to be negative, as I've explained in other videos where I've taught this before. So, two numbers that multiply to 60 but they add to negative 16 are negative 10 and negative 6. You may have to play with those a little while to get those. But now, since we have an a coefficient that's not equal to 1, we just can't simply substitute this into binomials. We have to take this negative 16y squared, and then we have to rewrite this. So I'm going to move this work up a little bit. And I'm going to rewrite this as 15y squared. So I'm going to rewrite negative 16y, not 16y squared, negative 16y. Yeah, that's right. So it's not y squared, 16y, my apologies. And that's going to get rid as negative 10y, negative 6y, and then we're going to bring down the plus 4. So in looking at these first two terms, what I can factor out of this, from 15 and 10, I can factor out a 5, and I can factor out a y. 5 times 3 is 15. Y times y is y squared. 5 times the negative 2 is going to be 10, and then y times 1 is y. So if we're getting 3y minus 2 here, as I've shown on other videos, we better be getting 3y minus 2 here, if this is done correctly. So from negative 6y and plus 4, from negative 6 and 4, we can factor out 2, but because this is negative here in this second part, we should be able to factor out a negative 2. And actually, that's the only thing that does factor out. And if you check this, negative 2 times 3y is negative 6y. Negative 2 times negative 2 is plus 4. So we have the common binomial in both of these. So that's going to be 3y minus 2. And if we cross that out, what we have left is 5y minus 2 here, then minus 2 here. And now we have factored that completely. So what did we use here? We used factoring by grouping to do this, as is necessary. And we split this up using the two numbers that we got from the X box. And that was, by the way, question 38. Question 39, that is going to be the difference of two squares. And I'll go ahead and pull the paper and let's take a look at that. So question 39 is going to be the difference of two squares. You should recognize that because this is a perfect square, this is a perfect square, this is a perfect square. So we have 81 x squared minus 49. So the formula reads, if we have a squared minus b squared, then the factors are a plus b times a minus b. So what we do is we establish that a squared is equal to 81 x squared. That means that the square root, or a, is going to be equal to 9x. If b squared is equal to 49, b is equal to 7. So if we substitute in, following this formula up here, we have 9x, we have 9x, plus minus 7 and 7. Plus and minus come from the formula. We have the b's being 7, we have the a being 9x, and there's 39 factored in its final form. I've burned through a lot of paper here, and we'll continue to burn through some more until we get every last question done on the practice test here. Let's go ahead and take a look at 40. It says, in this case, to factor completely. Another really kind of long question here, so let's see what this looks like. So we have 6x squared y squared plus 7xy squared minus 20y squared. Pretty brutal question, actually. Not a terribly fun one to look at or enjoy. For the numbers, 6, 7, and 20 don't have any factors, but notice that they all have a y squared. So we're going to factor that y squared out and make this just a little nicer to look at. So this will be 6x squared plus 7x minus 20. Now we can go ahead and use the x box, to determine how we're going to factor this by grouping. So 6 times negative 20, that's going to give me negative 120. And so we need two numbers that multiply to 120, but have a difference of positive 7. So two numbers that multiply to negative 120 have a difference of positive 7. And I could be wrong about this, but I think it's going to be plus 15 and then minus 8. So you have to play around with those to come up with those sometimes, and that can take a little time. But multiply these, you get negative 120, add them, you get plus 7. So I'm going to split this middle term up, as you should have seen in my videos when we do this before. So I have y squared times 6, and I'm going to bracket this actually, 6x squared. I'm going to put the negative 8x here. That way my second term here, that 15x, that's going to be positive, so I don't have to worry about factoring out a negative. So when I do the factoring of this here, I'm going to have y squared. Out of the first term here, I can factor out a 3. I can factor out not a 3. I can factor out a 2. So that's going to be factored out 2x. That's going to leave me with 3x minus 4. So I better be able to get 3x minus 4 out of this here. So what can I factor? If I factor 3 out of 15, that's going to give me 5. And I think that'll do it. 5 times 3x is 15x. 5 times negative 4 is negative 20. And there it is. So on the inside, we have 3x minus 4, 3x minus 4. So let me bring that out now. If I factor this out, it leaves me with 2x plus 5. Just remember, don't forget the y squared. Now at this point, if you just want to write it as, oops, guys, I apologize, I realized just out of view here. So if I factor out the 3x minus 4 here, it leaves me with 2x plus 5. And that's where that factor comes out of. So if you want to rewrite this now, we can write this as y squared times 3x minus 4 times 2x plus 5. So this type of factoring is a little more complicated and requires some practice on your behalf. Just remember, the first type of factoring you always want to look for is the greatest common factor. And now is question 40. Question 41. It says factor the binomial completely, and we have in this one, it reads x to the fourth minus 81. Now, not always, but in most cases, when you want to factor a binomial completely, usually means there's going to be more than one step involved. Hopefully you'll recognize that, again, this is going to be the difference of perfect squares, that if you have a squared equals x to the fourth, a will equal x squared, b is equal to 81, b squared is equal to 81, b is equal to 9. Well, if we apply the formula like we did last time, we're going to have here x squared plus minus 9 and 9. So the a goes here, the b goes here, plus minus. However, we have x squared minus 9. X squared minus 9 again is the difference of perfect squares. So I'm going to write this as x squared plus 9. Then if I write this out, the square root of x squared is x. The square root of 9 is 3, and I write plus minus. And now this is factored completely. And that is the answer to question 41. And that's the last question on page 5. We have one more page to go. And we're rounding down our review of the practice test here. It says find the sum or difference of two cubes. Now, I will show my technique for this. Count on one using the sum of perfect cubes and one using the difference of perfect cubes being on the test. In the practice test, there's 3 of these, okay? But I'll use my technique on this. So it tells you exactly what to kind of look for in the question. So 42 reads 343 y to the third plus 512. So your calculator should have like a cube root button, or you just may have to take a certain number, raise it to that to figure out what this is. So the formula for the sum of perfect cubes is going to be a to the third plus b to the third. Well, that's going to equal a plus b times a squared minus ab plus b squared. And as I mentioned in the videos where I teach this, we're actually going to figure out each of these parts all to the side. I want to know what a to the third is. I want to know what a is. I want to know what a to the second is. Then I want to know what b to the third is, what b is, and then what b to the second is. After that, the last thing I'm going to want to know is what is a times b. As I figure out all these missing pieces, this is a to the second. As I figure out all these missing pieces, it's going to help me to substitute into that formula to get this done. So a to the third, that's going to be equal to 343 y to the third. B to the third is going to be the 512. So the cube root of 343 is going to be equal to 7. The cube root of y to the third is going to be y. So a is equal to 7y. A squared is just the quantity of 7y squared, which is equal to 49y squared. If you have 512, the cube root of that is going to be 8. B squared will be just 8 squared, which is equal to 64. And then a times b is just 7y times 8. So 7y times 8, or 56y. So what's really nice about this, if you follow this formula, you're just going to take all the pieces that are over here. And what are the pieces here? What's a? 7y. What's b? 8. What's a squared? 49y squared. Minus, what's AB? 56y. What's b squared? Plus 64. And you're done. That's it. Those are the two factors. We can't do anything else with this other resulting trinomial. Once in a while, it turns out that there's something that can be factored, but there won't be an issue if you catch the factoring in the beginning. But here, there's nothing that can be factored from this binomial as it's shown. But these are the two factors for the sum of two cubes. Let's take a look at the next one, which is a bit simpler. Okay, and we have a to the third, b to the third, plus 64. So we have a to the third, b to the third, plus 64. So usually I use a and b to write this formula out, but I'm going to use different variables for it this time. So I'm going to just say x to the third plus y to the third, because I don't want to confuse the a's and b's here. That's going to equal x plus y times x squared minus xy plus y squared. So I'm going to start off by finding out what x to the third is. That's equal to a to the third times b to the third. Just see if we can fit this here. I'm going to find all these pieces as I outlined on my online instructions and as I've shown in class. So if x to the third is equal to a to the third times b to the third, x equals ab. X squared equals a squared b squared. Y to the third is equal to 64. The cube root of 64 is equal to 4. 4 squared is 16. And then xy is just ab times 4, or 4ab. So now I have all the pieces I need. I have this piece here, 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 and here to put into that form. What's x? ab. What's y? 4. What's x squared? A squared b squared minus. What's xy? 4ab. What's y squared? 16. And now that's completely factored. 43 is done. Since I've done this for 2 problems, I'm actually not going to do 44. I'll let you guys try that on your own. I'll show you 45. It's done in a very similar way. There's no difference in the method other than there's a slight difference in the formula, which you guys need to know. So 45 is the difference of perfect cubes, which is 27p to the third minus 1. So I want to know what a to the third is. A to the second, b to the third, b squared, ab. The formula for the difference of perfect cubes is a minus b times a squared plus ab plus b squared. All these formulas you need to know for the test. A to the third, that's going to be the first term here, 27p to the third. The cube of that will be 3p. If I take 3p and I square it, that gives me 9p squared. So make sure to do that work. B to the third is 1. B is 1. B squared is 1. AB is just going to be 3p times 1, or just 3p. So we all have all that worked out now. Putting in, we now have, what's A? 3p minus 1 times a squared, 9p squared, plus 3p plus 1. And now we have that worked out. So recall what I mentioned about the difference between these 2 formulas just being the signs that are here and here. Otherwise, the formulas for the sum and difference of perfect cubes are identical. And we have 5 more questions to go. 46. We're now asked to factor the trinomial completely. So we have one more of these to try to work through. So we have 8x squared minus 24xy minus 32y squared. The first type of factoring you always want to look for is the greatest common factor. And we can factor an 8 out of this. So this will leave us with x squared minus 3xy minus 4y squared. Hopefully most people can see that if I have 2 numbers here, that I have 1 times negative 4, that's negative 4, but they have a difference of 3. If I have 2 numbers that have a product of negative 4, but a difference of negative 3, this is going to be negative 4 times positive 1. So when I write out my factors for this, this will be x, this will be x, this will be y, this will be y. All we need to do is just put the minus 4 in, and then plus 1 we just write as x plus y. And we have our 2 factors for this here. So now I want to beat that one to death, as I have showed that question in my videos, and I would have gone over that question in class too. So there is 46. Let's take a look at 47 now. The last 4 ask us to solve quadratic equations. So you can count on at least one of these being on the test. If we're going to solve a quadratic equation, the first thing you must know is we've got to get the equation equal to 0. And in this case, it is for 47. So you will see this technique in class. So what I'm going to do with this now is I'm going to take x minus 6 times x plus 4, and I'm going to set this equal to 0. Well, the way we get this equal to 0 is either x minus 6 has to equal 0, or 4 has to equal 0. So how that's going to happen, and to find those values, we'll set x minus 6 equal to 0. We'll set x plus 4 equal to 0. And if we add 6 to both sides here, we get x is equal to 6. And if we set x plus 4 equal to 0, I subtract 4, and I get x equals negative 4. So there are two solutions that make that quadratic equation equal to 0. Now, that's if it's already factored for you, but that's not going to be usually the case for how you see this. Let's take a look at question 48. So you take a look at this here, you'll see this is a quadratic equation that needs to be factored now. I'm not going to show all the steps for the factoring because I will have shown a lot that you'll have seen a lot of these. I'm going to go right for the factors. So if I give you something that's easy to solve, or that I want you to solve as far as a quadratic equation, I'm going to make the numbers pretty easy to work with, all right? Because my focus is not your factoring. My focus is, do you know how to use the factors to solve the quadratic equation? So this is going to be x squared minus 13x plus 36 is equal to 0. So what I'm going to do is I'm going to put this into two factors, and the two numbers that are going to be a product of 36 but a sum of negative 13 are going to be x minus 4 times x minus 9. Negative 4 times negative 9 is positive 36. Negative 4 and negative 9 combine to be negative 13. So those are our two factors. Once I have the factors, I'm going to write x minus 4 equal to 0, x minus 9 equal to 0. And you don't have to show the division. If you know 4 minus 4 is 0, you can say that x is equal to 4. And here you just say x is equal to 9. I'm perfectly fine with that. Two more questions. Now, this question you may kind of see. In the question 49, what makes this tricky, we're going to have x squared minus x equals 56. If we're going to solve a quadratic equation, we must get it equal to 0. So what I'm going to do to solve this first is I'm going to subtract 56 from both sides. And that's going to give me x squared minus x minus 56 is equal to 0. Again, I'll let you worry about the long work of factoring if you cannot do this in your head, but I'm just going to give the factors here so that we can focus on the process of solving for it. So the factors of this are going to be x minus 8 and x plus 7. Okay, again, you can use the x box if you want to do that. Once I have my pair of factors, I can take x minus 8, set it equal to 0. I can take x plus 7, set it equal to 0. Here, this will give me x is equal to 8, and here, this will give me x is equal to negative 7. And that's going to be the answer for question 49. Last question. Hurrah, hurrah, hurrah. X squared minus 2x equals 24. I'm going to go ahead now and I'm going to get this equal to 0 by subtracting 24. Subtracting 24. So that'd be x squared minus 2x minus 24 equals 0. Now once I have it equal to 0, I can factor it. Again, I'm going to let you worry about getting those factors. I'm going to write this as x minus 6 times x plus 4. Gives me a product of negative 24, a sum of negative 2. Again, I'm going to set each of these equal to 0. And here I'll say x is equal to 6, and then x is equal to negative 4. And then we have our two solutions for that problem there. Well, that's all the work that will appear on your practice test. Hopefully you can use these as a study guide to help you prepare for the actual test. But be sure before you look at how these questions are done, look at my other instructional videos online and pay close attention to what's being done in class. Thank you and have a good day.